Let's now talk about geometric sequences and series. We start by talking about the geometric sequence. The geometric sequence, let's have an example on this sequence. This is 2, I have 4, I have 8, I have 16, I have 32, and so on. If you can realize, between each term, I simply multiply by 2. So now, in order to show that a sequence is a geometric sequence, the second term divided by the first term must be equal to the third term divided by the second term. This is to show that any sequence is considered to be a geometric sequence. About the geometric sequences, we need to know U1, which is the first term. We need to know R, which is the common ratio. In our case, it's 2. And we need to know N, which is the number of terms. Now, to find any term in N in a geometric sequence, we use UN is equal to U1 times R, which is the common ratio, to the power of N minus 1. This is to find any term in N in a geometric sequence. Let's talk now about a geometric series. A geometric series, I have 2 plus 4 plus 8 plus 16 plus 32 and so on. I can realize that now I'm adding all the terms. That's why I consider it a series. Also, in a series, there is a common ratio, which is, in this case, is times 2. Now, to find the sum of n terms, so the sum of n terms, I also write it as the sum of U1 from I equal to 1, this is I, to N. Now, the formula used to find the sum of n terms, I can use the sum of n terms is equal to U1 times R to the power of N minus 1 over R minus 1, or we can use the sum of n terms equals to U1 times 1 minus R to the power of N over 1 minus R. Both formula will give you the same result. So, by this, I can find the sum of all terms in a geometrical series. Let's now see a question from the IB question bank. A hydraulic hammer drives a metal post vertically into the ground by striking the top of the post. The distance that the post is driven into the ground by nth strike of the hammer is d of n. I have the distances, and the number of strikes is considered to be the term number. Now, the distance that the post is driven into the ground by the first strike, D1, is equal to 64. So I can know that 64 is simply the first term. The distance that the post is driven into by the second strike, D2, is 48. So this is U2. Part A of the question, we need to find the value of the common ratio of the sequence. So the common ratio is simply equal to the second term divided by the first term. So I have 48 divided by 64. So R is equal to, I need to use my graphical display calculator. It's 48 divided by 64. And this gives me 3/4, which is 0.75. So the value of the common ratio is 0.75. For part B, we need to find the distance that the post is driven into the ground by the 8th strike. So I need to find the value of U8, the 8th term. So this is equal to U1. U1, which is the first term, I have U1 to be 64, times the common ratio, which is 0.75, times n minus 1, which is 8 minus 1. So the value of the 8th term is simply equal to 64 times the 0.75, and this to the power of 7. It gives me 8.54 centimeters. So it's 8.54 centimeters. Let's go now to part C. Find the total depth. Since he says the total depth, it's clear that I want to find the sum that the post has been driven into the ground after 10 strikes of the hammer. So I want to find the sum of the first 10 terms. This is equal to U1, which is 64, times R, which is 0.75 to the power of n, which is to the power of 10, minus 1, over R minus 1, which is the 0.75 minus 1. And this will give me, also to find this value, I'll need to use my calculator. So I have a 64 times 0.75 to the power of 10 minus 1 divided by the 0.75 minus 1. And this is equal to 241.5. Rounded to 3 significant figures, it gives me 242 centimeters. And by this, I could solve this question on geometrical sequences and series.